All right, so function operations. Again, you guys are going to be able to add, subtract, multiply, and divide these functions, okay? Again, a very simple lesson for today. So to start off with addition, when you are adding two different functions, okay? All you have to do is combine your like terms, okay? You are adding the f function to the g function, okay? Now, yes, I did put this in parentheses because I am adding these two functions together, and this one just so happens to be a negative. But when you're adding, you can just drop the parentheses and then adjust this accordingly, yes? Okay, so this is really just 3x plus 2 minus 2x minus 8, and we combine our like terms. 3x with a negative 2x, which make what? X. And then 2 with a negative 8, which make what? Negative 6, okay? Please do not try to add 2x to 3x here. That's not correct. Do not do that. The only time where you actually do something like that is if there was an equal sign and you're trying to move your x's to the other side, okay? You're literally just combining like terms. Another way that this could be represented is like so, okay? So these two mean the exact same thing. So don't get confused. You're literally still just adding the two functions together. Yes? Okay. I want you guys to do the second one. And as tempting as it may be, don't go forward. Don't go ahead. Just kind of stay with me. Okay? I want you guys to do number 2. All right. So what you guys get for your final answer? Anyone? Yes? Wonderful. If you notice, too, especially with one like this, you see how everything's all nice and pretty and lined up and everything like that? You just add straight down. So there's 12 here and then here. Very nice. Addition's good, yes? Wonderful. All right, let's move on to subtraction. Now, subtraction can get a little sticky, especially if you're trying to be all big and bad and thinking that, you're invincible or anything like that, okay? The reason why this one can get a little tricky is just because of the fact that there's a minus there. You're subtracting the entire second function, okay? Do realize this is the same thing as saying f of x minus g of x. So you're subtracting that entire function, which means that parenthesis, that I drew before with the addition, there's actually an effect here. We have to do what? We're going to have to distribute that negative, okay? So anytime you're doing subtraction, you want to make sure that you carry over that negative, okay? So really, it's saying 5x plus 2, and then what? Plus 9x plus 2. Then you combine like terms again. 5x plus 9x, 14x, and then 2 and 2. Wonderful. Yes? Great. Do number 4. Do number 4 on you. All right, so looking at number 4, definitely make sure that negative gets distributed to the entire 7x squared minus 5x plus 6 to turn into a positive, not a positive, bless you, a negative 7x squared plus 5x minus 6. Did you do that? What's my final answer? Very good. What's the domain of that? Say again? All real numbers. How do you know it's all real numbers? No radical, and there's no denominator involved at all. Good stuff. All right. And actually, what kind of function is that? So what? Quadratic. Because that's a square. Remember the U. Okay. Just a little bit of review in there. Just a little bit of review. Multiplication. You are going to multiply these functions together. Okay. So, as tempting as that dot may be to put a dot in between the two, why don't you go ahead and trade that dot out for, what do you think I want to say? Parentheses. Because maybe you'll see it that you're going to need to do what here? Box method, I heard. FOIL. Distribute every term in the first parenthesis to every term in the second parenthesis. However you multiply polynomials, okay? If box is your friend, wonderful. You like FOIL? Good. If you just like distributing the numbers through, that's fine too. See the claw, the crab claw? There you go. 3x times the negative 2x. Negative 6x squared. Make sure that when you're multiplying, x times x is x squared. Outer 3x times negative 8. Negative 24x. 2 times negative 2x. Negative 4x. And then 2 times negative 8. Do I have any like terms I can combine? Sure do. So my final answer is negative 6x squared minus 28x minus 16. Questions? Do number 6. All right. So when we bring it back, when I multiply negative 2x to everything in the second parenthesis, what do I get? 12x cubed plus 6x minus 6x squared minus 14x. You probably said that. I just didn't hear it. And then when I multiply 5 to every term in the second parenthesis, I get and then I add everything up or subtract necessarily, and that's negative 12x to the third Questions? Wonderful. What's the domain of this? All our numbers. What about in interval notation? What is it? Huh? Negative infinity to infinity. Inclusive or exclusive? Okay, well, is it inclusive or is it exclusive? Exclusive, right? Because inclusive means that you would include them. Exclusive means you would exclude them. There we go. All right. I hate for you guys to get a word problem that says inclusive or exclusive. You're like, oh, crap. All right. So here we go. Division. Rounding it out with division. Okay. Do be very careful because once we do the division, we could potentially create a fraction, which means that we would need to state values that would not work, okay, with domains and stuff like that. So here we are dividing f by g. And we want to make sure that we simplify. Okay, we do want to make sure that we simplify. Since g is a monomial, it's only one term, we can divide every single term by that 2x squared. Okay? And use that to basically simplify everything. So I could do this, this, as well as this. Okay? can only do that because I have one term in my denominator. If it was flip-flop, I could not do it. Okay? So, what is 8x cubed divided by 2x squared? 4x. Yes, because 2 divided by 8 is 4. X cubed divided by x squared is x because I have 3 x's on the top and 2 x's on the bottom. So 2 cancel out. Let's move one on the top. What's 4x squared divided by 2x squared? Plus 2. And then what about this last one? 12x over 2x squared. Can I simplify that anymore? I can. It is a question. Oh, no. Don't do that. Okay. Remember, this is nothing but 6 times x, just like this is nothing but x times x, right? So just real quick, I'm going to do it up here. 6 times x. Yep, it would just be 6 over x because you can cancel out an x because they have it in common. So this would actually be 6 over x. That would be the most simplified answer.
What is the cube over the square?
So this is basically this. So then canceling out common factors. And then this divides into 4. So it's just left with 4x. X cannot equal what number? So anytime it asks you to state any exclusions or any restrictions or excluded values, that's what they want you to do. Whatever values that will make this undefined. Okay? Do number 8. What's my final answer? And x cannot equal what number? Questions? That's the bulk of it. Does it get more complicated? Depending on the function that's given to you, yes, it can. Okay? Do realize that we have a whole nother complete section that's going to go when we're dividing actual polynomials and not monomials. Okay? So for this particular section, these are going to be as complex as the division ones are going to get, but they can get more involved. But that's for a whole nother different section. Okay? On your desk, I want to practice some, just a little bit. Okay? If I gave you a problem like this, and I said, what is the sum of f of x and g of x? What would you do to these two functions? Wonderful. If I gave you these two functions, and I said, what is f of x increased by g of x? Ooh. Would it be addition or would it be multiplication? It's actually going to be addition, increased. Okay, even though as much as I wish that when they said that we get an increase, I would love for them to multiply my paycheck. It is nothing but an addition. Okay, it is nothing but addition. So increase by means addition. Okay, what about find the difference of f of x and g of x? I'm going to subtract which function goes first and which function is going to go second. F of x first minus g of x. Okay? What is g of x decreased by f of x? And which one is going to go first? Which one's going to go second? Very good. Find the product of f of x and g of x. Multiplication. Very good. And very good. Find the quotient of f of x and g of x. And state the constraints. I want you guys to do this one on your desk. So let's see about this one. You have to find the quotients, which means you have to do what again? You got to divide. So I'm going to take x to the 6th minus x to the 5th plus x to the 4th and divide it by x squared. When I divide it by x squared, what am I left with? What are my constraints? So is there any constraints? No, there are none. Slightly a trick question, okay? Because remember, if there's no fraction, there's no radical, there's no need to have any constraints. There's nothing that's going to not make this defined, okay? Taking it up a step. I want you to find the perimeter of this lunchbox. Yes, that is a rectangular lunchbox. You know, from when y'all were children. Let's start out with the most important question of all. What is perimeter? Addition of all the sides. Now, if this is a rectangular lunchbox, that means what's this side over here? And what's this side up here? So I'm actually going to add all of these up together. Some of you guys, you were multiplying. Some of you guys doubled the size, which is perfect, you know, from your old school knowledge of 2L plus 2W, but then you multiplied them together. No multiplication involved. It's just x plus 3 plus x plus 3 plus x plus 7 plus x plus 7. Which gives you a whopping total of how many x's? And what's the number? And that's your perimeter. If there were units involved, or let's say this is centimeters, then this would just be 4x plus 20. Okay? All right, clear your desk. What about this? The perimeter of the triangle is 4x plus 3y. Find the measure of the missing side. Taking it up a step. This here is still doing operations, but this time we're actually finding a value for it. Okay? If you notice, this is different from the other ones. Why? Why is this different? Why are these different operations different from the other ones? With extra numbers instead of the equation, and there's no what? What's normally here? What would normally be right here? It'll be an x, but now it's a number. So this means that instead of having an x there, I need to have a negative 1, or a 2, or a 0. Okay. There's one of two ways. You can either do the operation and then plug in the number to get your answer, or you could do plug in the number for p into p, plug in the number into q, and then whatever those numbers are, add them together. So essentially that's the same thing. Okay, remember how I showed you that this is the same thing as this? Yes? It applies as well when you plug in a number. So it's up to you. It's your choice. Either do the operation and then plug in a number, or plug in a number from the beginning and then do the operation. Okay? So, but no matter which way I do it, I still get my same answer. So if I decide to add these two together to start, I'm going to get a negative 2x squared plus 7x plus 0 if I add them together. Then all I need to do from here is just plug in negative 1. And please be careful. When you plug in negative 1, especially if an exponent is involved, what do you do first? The exponent. So it's negative 1 squared times negative 2 and then 7 times negative 1. So my answer would be negative 9. Does that work out? Yeah, that works out? Okay, cool. If you want, again, you can plug in negative 1. What's 3 times negative 1? Minus 1. When I plug in negative 1 here, this becomes what? Negative 2 minus 4 plus 1. What's negative 2 minus 4 plus 1? And that's still what? To be honest, it's about the same amount of work no matter which way you go. Okay? So, I want you guys to do number 2, and I want you guys to do number 3 on your desk. Can everybody see it? Do you want to make it larger? Here's subtraction. Question. For which one? I did use negative 1. You see how I plugged in negative 1 into P? So then I have 3. So when you're looking at this, what did you get for number 2? Going to do 2 and 3 on your desk. Its answer is 4. What'd you get for number 3? 2. 4 is the first one, and 2 is the second one. Do I need to work either of those out? Which one? Number 2. Do you want me to do it by plugging in or doing the operation then plugging in? Okay, I heard more plugging in. This basically means I'm going to do P of 2 and then subtract it from Q of 2. So that means I have to plug 2 into the P function. 3 times 2 minus 1, 5. So that's P of 2. I'm going to subtract that by whatever Q of 2 is. That means I have to plug in 2 in for X. So that's P of 2. Every X. Order of operations, 2 squared times negative 2. 4 times 2. Order of operations, 2 squared. So that becomes what? And 5 minus 1 is 4. Okay? So that becomes what? And 5 minus I want you guys to do these. 4, 5, and 6. 4, 5, and 6. I want you guys to do these. 4, 5, and 6. 4, 5,